All right, this is where I left off, where I ran out of time, and I warned you that this is kind of a lame explanation if you only had 1 point. So I talked about at least getting 2 points for the parent function of exponential growth because the base is larger than 1. And going through this process that we've talked about already, where you could find out the best ordered pairs for this function by doing these transformations. So if I plug in 0 for x, the new ordered pair would be -3, and plug in 1 for x, well, the negative of 1 is -1 minus 2 is -3. That's the point I already showed you. Well, where's this point going to be then? And part of the reason why I'm not a big fan of doing a bunch of points is because I don't like fractions. I don't think many of you do either. But in this case, we can at least figure out when x is 1, we get -4. And with y being 3/2, we'd have -3/2 minus 2. -3/2 would be about -1.5, so -3.5 would be -7/2. -3.5, so that would be like right here. Uh-oh, well, it's a good thing that I did this because now that I'm looking back at, and I must make a note in my slides that I made a mistake on this, because I wrote that we had an exponential growth with 2 reflections. I'm sure some of you wrote this question down because you guys are pretty smart, that I should have ended with an exponential growth on this, which is why it is good to double check your work in multiple ways. So hopefully, even if you copied down that problem from the first video, you kept watching to make sure that you get the correct answer. And don't be afraid to use your calculator either if you have the chance to use it. So if you use your calculator, you can type in -3/2, double checking out the right equation, to the, and some calculators you need to put in parentheses. Make sure you hit the negative key, -x minus 3, and then -2. -2. There we go. And I always move my calculator around, so I have to hit zoom 6. And there we go. We have the correct answer. Now, just one more thing is you can hit second graph to look at the table. And my table is set pretty far away, but you can double check that I got -4 and -7/2 correctly. So sorry I messed it up on the first video, but I fixed it here. I'm not going to go back and redo a 15-minute video though for that one tiny mistake that we have already fixed. But feel free to write down any questions, or if you are confused on anything, to bring it to my attention so we can clear that up. And then we have another problem where we are examining h of x, and notice in the directions that h of x has a y-axis reflection. X is negative, we have a y-axis reflection. So as we look at this, it might be to your benefit to go ahead and graph these points, x and y-axis. It looks like my horizontal asymptote might be a little bit above the x-axis. I don't want to give too much away yet. I don't like my graph. Let's fix my graph. Because now that I'm looking at all of the values, I get very large numbers. So I want to make my axis a little bit lower. So -3, 9, -1, 3, 1, 1.5, and then very close to this horizontal asymptote, and very, very large numbers over there. So as I'm looking at this now, that might help you understand that we have exponential decay. As we move left to right, decay because we have a decreasing function. And remember, we read the graph left to right, so x value is all the way to the left. Kind of gave away this answer by showing you the graph, but if you still have questions, as x goes to -infinity, I would say h is going infinitely up. I realize that 513 is not the largest possible number, but we can only make the table so far. So that's a very large number, so I think it's safe to assume that it's going infinitely up on the left side, but to the right, we're getting closer and closer to a y value of 1. Now the domain and range. I think using the graph is extremely helpful. To me, the domain in this problem is all reals. That should be the case for all exponential functions, but because we read the range from bottom to top, I'm going to go from the horizontal asymptote of 1, and it's going infinitely up. Wanted to highlight something real quick. Highlighter 1 and 1, which is also going to be used here for the equation of the horizontal asymptote, is y equals 1. That number is going to be repeated. So then number 5, what can we conclude about the a value? Now we could figure out what the a value is, if we really want to. But right now, let's just talk about the fact that we're above the horizontal asymptote. And so if we are above the horizontal asymptote, we need to be bigger than 0. And that's all I need, is that because we're above the horizontal asymptote, and you could stop right there, but I want to write down this implies there is no x-axis reflection. So it's not negative. And what can we conclude about the b value? Well, we had a y-axis reflection, so there's one reflection, no x-axis reflection, and we have decay. Well, if we have a decay function with one, let me write that down, decay with one reflection means that my base needs to be bigger than 1. Implies, that's my symbol for implies, by the way, the base is larger than 1. There's your reason. Decay with one reflection, base is larger than 1. And what about what we can conclude about c? Well, I'm getting a highlighter out for a big reason. So we've already seen that number a couple times. The c value being the shift up and down. So that's the same thing as the equation of the horizontal asymptote. What's your reason? It's the equation of the horizontal asymptote. Another reason could be it's your shift. You're shifted up 1. So sorry I made a mistake in the first video, but hopefully how short the second video is kind of makes up for that. But you should be ready for the free response question. Notice that the answer key is already provided, so I don't feel bad that you have a rather large homework assignment with a couple free responses, because the free responses are given to you. The answers are, at least, so you can double check. And then we have the review, and then the test is coming up. Again, I meant to cross off all of these answers. Sorry about that. But the answers to the review are already in here. So that's why it's an ungraded assignment. Just flipping through here, I noticed that the author of this uses the phrase decreases without bound. If you ever say decreases without bound, you can also say it's going to infinity. The fact that it's decreasing without bound would say it's going to negative infinity. Calculus teachers have gotten away from this phrase, but I've still seen it on like AP tests from 20 years ago. And then if you're increasing with bound, that's basically saying we're going to a horizontal asymptote. So you don't have to write the answers the way the answer key is, and I just happen to look at this. So if you want to use this phrase, go ahead. I'm actually a bigger fan of using the infinity symbols than this phrase. So don't let that scare you either when you get to that assignment. So go ahead and get to work on your assignment.